All right, welcome back. So now we're going to talk about factoring special cases. Now I want to make it very clear that it is okay if you do not recognize that you have a perfect square trinomial or a difference of two squares. All right, you can use the AC method with any of these, okay, and still come up with the right answer. So I just want to point that out because I can normally catch the difference of two squares much easier than I can catch perfect square trinomials. So again, just wanting you to know. These are just special cases. They can, they're giving you a pattern, a shortcut that only helps in these specific cases. But yes, it's okay if you factor by grouping these as well. All right, so the patterns. Perfect square trinomial, if you have a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, then you end up with, I hit that spot on my board, a plus b quantity squared, or a a minus b quantity squared. The plus and the minus all come from what's the sign in the middle. And again, it has to be that our a and our b are both squared, but that if I take the square root of each of those times each other and then times 2, I'll get the middle number. And we'll get some practice with that in just a second. Difference of two squares, this one I think is the easiest one to spot because it's a squared minus b squared. It only has two terms. Like you can ask yourself these like 3 questions. 3 questions. Is it a binomial? Is it subtracting? Are both terms perfect squares? And if you say yes to all 3 of them, then you're going to do the following. If you say no to any of them, then it's not a difference of two squares. So if you have the difference of perfect squares, you're going to do a plus b times a minus b. Like I said, to me, it's the easiest one to recognize because it's not a trinomial, it's a binomial, and you're just looking for perfect squares with a binomial that are subtracting, subtracting. So, all right, let's practice. So here we have a perfect square trinomial. I'm telling you it's a perfect square trinomial, but how do we check it? Well, right now we know that a is 1. We know that c is 36, right? So if I were to square root those, right, square root of 1, square root of 36, I would end up with 1 and 6. And 6 times 1 is 6, times 2 is 12. So it fits my a squared, in this case minus 2a, not again, 2ab plus b squared. So from here, I just put my set of parentheses. I take the square root of a, which in this case is going to be 1x or just x. My middle sign here is going to match the middle sign there. So it's going to be minus, and then the square root of 36 is 6. And then I just put a square on the outside of my parentheses, and that is done. That is done. Now, that doesn't mean that you can't go, okay, well, 36 is 1 and 36 and 2 and dot, 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 right? And continue that way and do it as 2 sets of parentheses, and then, I can write it this is okay. This is just the shortcut if you notice the pattern. That's the only reason I'm showing you these, is so that in case you notice the pattern, you can use the pattern. All right. Difference of two squares. Again, is it a binomial? Yes. Are they subtracting? Yes. Are they both perfect squares? We've got 16 and 81. The answer is yes. So this is how I do these. 2 sets of parentheses, 1 plus, 1 minus, I know I'm going to have an x, well, whatever my variable is. In this case, it is x. And, excuse my mess up over here as my pen's messing up on me. Square root of 16 is 4, so I have 4x for my front. And the square root of 81 is 9. So we have 4x plus 9 and 4x minus 9. And that is it. Now if you're like, but what if I don't remember that? Okay, well then rewrite this as 16x squared plus minus, doesn't matter, 0x. Maybe 0x minus 81. And then from there, you are just AC methoding it. So, your choice. But that's how both of these work. You can do it without the patterns, but here are the patterns to make it easier. I hope you have a wonderful day, and I will see you in class.